Okay. Hello, everybody. So off we go to chapter 9. Okay, so what are we looking at in chapter 9? First section deals with the um, features of a perfectly competitive industry. And the second part looks at the optimal output quantity for, for an individual firm in the perfectly competitive industry. And then, then we look at oops. Why the supply curve for both the firm and the industry as a whole equals the marginal cost curve above the shutdown point, otherwise known as the average variable cost curve. And we look at how the perfectly competitive industry adjusts to short-term disequilibrium so that the market eventually comes back into equilibrium in the long run. And finally, we look at these three possible shapes of the long-run supply curve. The curve can either slope upwards to the right, downwards to the right, or it can be flat, depending on whether the industry experiences increasing input costs, decreasing input costs, or constant input costs. And then finally, we look at the social evaluation of perfect competition. Okay, so off we go. Okay, so first section here, characteristics of perfect competition. So when we speak about industry organization, we're talking about the environment or the industry environment or the market structure that affects the behavior of the firm and its financial performance. And when we talk about market structure, we have these six variables that we can use to describe an industry. We can look at the number of firms in the industry, the number of vendors, the number of producers, how easy it is for companies to enter the industry or to exit the industry. It's not as easy as it might sound. I mean, exiting an industry is not necessarily an easy thing for companies to do, especially if they have large capital investments. Okay, then we can also describe an industry in terms of how easy it is for each firm to set the price of its own product. And we can look at the degree of product differentiation between different vendors. I mean, do different vendors sell essentially the same product, or are there some differences there? And then there are a couple other factors here that we can use to describe an industry. The degree to which a company can compete on non-price factors, and the degree to which an individual firm can earn economic profits. And we know that in perfect competition, or we will come to know that in perfect competition, in the long run, economic profits are not possible, and firms only compete on the basis of price rather than non-price features. Okay, so let's just move on. Okay, so in perfect competition, the dominant market structure is the inability of the individual firm to control its own price. And that means that firms essentially are price takers. So in perfect competition, we have many small producers, and none of them have any control over the price. So effectively, the product price is given to the firm, which means that it's set by factors outside the control of the firm. And so the company is a price taker rather than a price setter. Okay, so why are individual firms in perfect competition price takers? Well, we've seen already there are a large number of vendors, and they're all small producers, and so no producer has any control over the price. In perfect competition, the products of the different vendors, of the different producers, are effectively the same. Products are effectively a commodity, which means they're homogeneous across different firms. And so the product of each firm can be easily substituted for the product of another firm. Okay, so as you saw earlier, in perfect competition, it's easy for new companies to enter the industry, and it's easy for existing members to exit the industry. So if our industry starts to generate some short-term economic profits, competitors will quickly enter the industry, and if the industry temporarily suffers some economic losses, then some of the existing players will exit and get out. Okay, and then the final reason why an individual firm is a price taker in perfect competition, it's due to the presence of so-called perfect market information. So on the one hand, it's easy for the buyers to find out the prices that all the different vendors charge. So it's easier for buyers to shop around. And likewise, the vendors in the industry, they are not able to keep any industry secrets. So if somebody develops some new technology that makes the industry more productive or more efficient, then it's very easy for all the firms to find that out. And so they'll all jump on to the new, more efficient technology. Okay, let's move on. Okay, so this is the industry. So we saw earlier in the course that in equilibrium, the equilibrium price and the equilibrium quantity are set by the intersection of the industry supply and demand curves. So this holds true in perfect competition. It doesn't hold true in some of the other industries that we're going to look at, but it holds true in perfect competition. However, in perfect competition, so here's the industry, so here's the downward sloping demand curve, upward sloping supply curve, equilibrium price, equilibrium quantity. In perfect competition, we need to draw a distinction between the shape of the demand curve that the industry as a whole faces from the shape of the demand curve faced by the individual producing company. So for the industry as a whole, the demand curve slopes downwards to the right, but for the individual firm, it's effectively horizontal. Why is it horizontal? Because each individual firm is effectively a price taker. So there are forces outside the firm's control that set the price. The price is $5, and if the individual firm wanted to charge more for its product than the industry price of $5, if the firm increased its price to $5.01, right to here, then the demand for that company's product would completely disappear. The firm is welcome to sell as much as it can at the market price, but if it tries to increase the price, its demand will evaporate. And so this horizontal demand curve effectively means that the demand curve facing each individual firm is perfectly price elastic. So I have to admit, to me, this is a little bit counterintuitive. I mean, normally we would think that the industry demand curve should be the horizontal summation of the demand curves of each of the individual firms, but that's not what the theory says. And so to me, it's a little bit counterintuitive. However, it's not completely unusual that the whole looks different than some of the parts. We have the saying that something was the straw that broke the camel's back. We know that an individual straw does not contain enough weight to break the back of a camel. However, if the camel already has, 100,000 pieces of straw already on its back, then one more straw added to the cumulative weight of all the other previous straws may be enough to break the camel's back. So although one individual straw does not have enough back breaking capacity, when it's added to all these other straws, it does. And so the property of an individual can differ than the property of the whole. And so that's kind of true with our straw example, as with perfect competition. The properties of the demand curve for the individual firm are not the same as the properties of the demand curve facing the entire industry. Anyways, it's a bit counterintuitive, but it's the way the theory works. Okay, so the next little section looks at the optimal quantity of output that each individual firm should produce. Oops, just a sec here. Clicked the wrong one. Okay, we're good. Okay, so in perfect competition, the optimal quantity of output for an individual firm can be determined using two methods. One is based on total revenues, total costs, and total profits. And the second approach is using the per unit basis, so it's per unit revenues, per unit costs, otherwise known as marginal revenues and marginal costs. So what we're going to do next is walk through a numerical example of both these approaches. Both approaches use the same data, and then we're going to see that the two approaches are equivalent because they arrive at the same optimal quantity of output. And this optimal quantity of output for these two approaches is the same whether we assume the firm is experiencing economic profits, short-run economic profits, or whether it's experiencing short-run economic losses, or whether it's at a break-even point, and so there are neither economic profits nor economic losses. Okay, so first we look at the total approach, total revenue and total cost approach. Okay, so we mentioned before that in perfect competition, an individual company has no control over the price it receives for its product. And so the profit maximizing quantity, so the firm, to maximize its profits, only has to determine its profit maximizing quantity. So the profit maximizing point is where the price minus the average total cost times the quantity is maximized. And really what this means, this is the profit margin per unit times number of units. And that's our profit maximizing rate of output. Okay, and as we know that in economics, when we talk about economic profit, that's total revenue minus total costs. And by total costs, we mean both explicit costs, which are accounting costs, and implicit costs, which economists like to call opportunity costs. Okay, so we have these two methods. So we're going to look at the first method, the total revenue and total cost method of finding our profit maximizing quantity. So we have a data table here. So on the leftmost column, we have the total quantity of output, so 0 units, 1 unit, 2 unit, price of the product, $5. Total revenue, so price times quantity, total costs, and there we have total profit. So the authors kind of have this backwards. I mean, here's column A, column B, and column C. So column C equals A minus B. Anyways, usually you put revenues, costs, and then net income at the end. Okay, so if we have this table of data, we can see that as our quantity of output increases, our total profits increase up to a certain point. And if we go past that certain level of output, our net income starts to decline, so it starts to decline. So we can, just by reading this data off the table, we can see that our profit maximizing quantity equals 7. So we can just eyeball that. And of course, if we chart all this, we can see the same thing in chart form. So that's all we've done on this slide here. Here's our quantity of output, DVDs. Here's our total revenue, so it's market price of $5 each, total revenue, total cost, total profits. The green line is total revenue line, the black line is total costs, and so the difference between them is the net income. And although this isn't exactly perfect, the profit maximizing quantity is the point where the vertical distance between the total revenue line and the total cost line is greatest. And again, we can just kind of eyeball that and see that that occurs at 7 units. Okay, so that's our profit. That's determining our profit maximizing quantity using total revenue, total cost, total profits. So we can arrive at exactly the same point using marginal revenues and marginal costs. So we know that marginal revenues equal change in total revenue divided by change in output, and marginal cost equals change in total cost divided by change in total output. And we're going to see that the profit maximizing quantity is the quantity where marginal revenues equals marginal cost. That's our rule. And this rule, so this rule applies for perfect competition. It also applies for monopoly. It also applies to monopolistic competition, but we'll see that it does not apply to oligopoly when we get there. Oh my goodness. Okay, so here's our data table again. So here's our quantity of output on the left-hand column. So that corresponds to the x-axis. Here's our marginal revenue. So here's our marginal revenue curve, which is equals the demand curve, which equals $5 in this example. And then we plot our marginal cost. That's our red curve here. And we see that the marginal cost intersects, so marginal revenue equals marginal cost at 7 units. Same 7 units that we saw in the other approach. Okay, so let's just move on. Okay, so our next little question is, why in perfect competition is the quantity corresponding to the point where marginal revenue equals marginal cost the profit maximizing quantity, or the optimal quantity? So here's our marginal cost curve, the red line. Here's our marginal revenue line, the blue line. So marginal revenue is the demand curve. This only occurs in perfect competition. So if we start over here at quantity 0, so if we look at this range between quantity of 0 and our equilibrium quantity right here, where the two curves intersect, so in this little section of the curve here, as we increase our quantity, we see that the difference between marginal revenue and marginal cost is positive. So as we increase our quantity of output up to this point here, our profits increase. So as we increase our quantity up to the point where marginal revenue equals marginal cost, then our net income can be increased by selling and producing additional units. And then, so we're going to use a process of elimination here to see why our optimal quantity is the point where marginal revenue equals marginal cost. Okay, so let's look at the opposite situation. So let's look at, oops, didn't move. Oh my goodness. There we go. Sorry. Okay, so let's look at this section of the chart. So so again, our question is, why in perfect competition is the quantity corresponding to marginal revenue equals marginal cost the optimal quantity? So if we're producing and selling quantity in this section of the curve, we see that marginal costs are greater than marginal revenue. Because remember, our demand curve is the marginal revenue curve. So we're suffering losses. So as we decrease our quantity of output, our losses decrease. And once we get to the point where the marginal revenue equals marginal cost, our losses disappear. So as our quantity decreases, we're effectively we're reducing our losses, and we're effectively reducing our losses. I don't know why I have to click it twice. Anyways. Okay, so sort of in conclusion, if we're operating at a quantity less than our equilibrium quantity here, our marginal revenue exceeds marginal cost, so we can increase our profits by increasing our level of output. And if we're operating in this section of the curve here, our marginal cost exceeds marginal revenue. So we can decrease our losses by reducing our output. And so again, we gravitate to this optimal quantity where marginal revenue equals marginal cost. And again, in this example, that equals 7 units. Okay, so the next little section looks at kind of demonstrating why these two approaches are equivalent. Oh my goodness. Why they're equivalent. Oops. Sorry. Oh, okay. So why these two approaches give the same result? Sorry, I was on the wrong page. Okay, so our first approach, we want to determine our profit maximizing quantity based on looking at total profits. And from our little data chart here, we saw that our profits are maximized when the quantity equals 7. So that's profits are maximized at 553 in total. And we can likewise eyeball the data chart, and we can see that marginal revenue equals marginal cost, also at 7 units. So it's not perfect here. The marginal cost is $4.99, but it's we're going to round it off to 5. So again, we see that the profit maximizing quantity corresponds to the quantity where marginal revenue equals marginal cost. So those are our two approaches. Oops. Okay. So again, we can kind of see these two approaches come to the same conclusion. So this little chart assumes that we're experiencing economic profits. This assumes that we're experiencing economic profits. So economic profits, so here's our price line, the blue line, and here's our average total cost line, the black line. So we see that our price is greater than average total cost. So so price minus average total cost equals net income per unit. So we can see in this diagram that we have economic profits. So when we use, so this little chart here is quite difficult to read because there's so much data on it. But anyway, so we have total revenue, total costs, total profit, same data as before. We see that our profits are maximized at 7 units here. And likewise, when you look at the marginal revenue and marginal cost approach, we see that where they're equivalent, so it's not, again, it's not absolutely perfect here, but at 7 units, at the profit maximizing point, marginal revenue equals marginal cost. So I wanted to point out here, on this little slide here, I've made a change from the slide that is posted in Moodle. Sorry. In the slide that's posted in Moodle, this little line here is pointing over here. It's pointing to the minimum average total cost, and that's a mistake. It's a mistake. Because our profit market maximizing point is where marginal revenue equals marginal cost, which is red, and that's at this point here. It's not the profit maximizing point. The profit maximizing point is not at the point of minimum average total costs. Rather, the formula is profit maximizing point is the point where price minus average total cost times quantity is maximized. Not the point of minimum average total cost. I do have room here. Okay, so I didn't know I could print over there. So anyways, I calculated average total cost here, and this profit maximizing point right here is not the minimum average total cost. Minimum average total cost is right here. Average total costs are 4.08. This is the minimum average total cost. And at a quantity of 7, average total costs are 4.21. And on the other side, it's 4.30. So the point I'm trying to make here is that the point of minimum average total cost is not the profit maximizing quantity. It's this point here. It's quantity where profits are maximized by profit margin per unit times number of units. Okay. So in this little example, we assume that we had economic profits, and we see that the with these two methods, our profit maximizing quantity is where marginal revenue equals marginal cost. We can look at that, see that on either a total revenue minus total cost equals total profit basis, or using the per unit basis, marginal revenues and marginal costs. Okay, then the next slide. The next slide actually shows the same thing. It's just taken off the data table, but it shows the same thing. Profit maximizing quantity is the point where marginal revenue equals marginal cost. In this case, that equals quantity equals 7 units. Okay, so the next little example looks at economic losses, and we see the same thing. Our economic losses are minimized at the point where marginal revenues minus marginal cost, or okay, so using our first method again, we have total revenues, we have total costs, we have total profits, and we see in this little, oops, sorry, in this little example, our losses are minimized at 6 units using the total revenue, total cost approach. But we also see that when we use the marginal revenue and marginal cost approach, marginal revenue and marginal cost equal each other. We're 2 cents off, but we're not going to worry about 2 cents. Marginal revenue, marginal cost are also equal to each other at 6 units. And so that's the same result that we used from the first approach. And so in our little diagram here, we have average total cost is our black line. Our marginal revenue line is blue. And our loss minimizing point is the point where marginal revenue equals marginal cost, which is the intersection of the red and the blue right here at 6 units. So whether we do it in chart form or numerical form using the first approach or using the marginal revenue, marginal cost approach, we're going to get the same answer. Okay, so the next little section deals with the shutdown point. We're kind of getting into the we're warming up to why the marginal cost curve above the average variable cost curve is the supply curve for the firm in the industry. But anyways, first we look at the so-called shutdown point. So the shutdown point is simply the point where the business stops operating, at least on a short-term basis, and they stop operating because they can't afford the losses. So, okay, so the shutdown point is the point where our price, oh, I'm going to erase here. There we go. So the shutdown point is the point where our price equals average variable cost. So this is price per unit, average variable cost per unit. Why is it? So in this little diagram here, here's our average variable cost curve. The black line is our average total cost line. And we know from earlier that the marginal cost curve intersects the average cost curve and the average total cost curve at the minimum point. So these green points are the minimum points on the average total cost curve and the average variable cost curve. So at this point here, I don't know what it is, 4.5 units or whatever, 4 units. Our price per unit covers all of our variable costs. And at any quantity less than this, our price, here the red line is our average variable cost curve. At any point to the left of here, our average variable costs are greater than our price. So our price is not sufficient to cover all of our variable costs. So we're better off shutting down rather than wasting money on these costs. And so we're better off shutting down at this point and not wasting money in the variable costs. Yes, we still have to incur our fixed costs, but we have to incur those regardless. Okay, so if the price is less than average variable cost, which it is in this region here, then we're gonna shut down. And once we make it up to this point where price equals average variable cost, we're gonna start operating. We only make profits from when the price exceeds average total cost, but we'll operate even though we're losing money in this section here, because we're at least covering all of our variable costs and we're making a contribution to fixed costs. So we'll operate from this point on. Okay. Oops. Okay, so this kind of illustrates the same thing, that the shutdown point corresponds to the point where price equals average variable costs. And again, that's also the point where marginal revenues equals marginal cost when average variable cost is minimum. Why is it minimum? Because that's the point of intersection of the marginal cost and the average variable cost curve. Marginal cost curve intersects the average at the minimum points. Okay, and then the final little point here, final little point is the so-called break-even point. Oh, I can't see it. Oh, okay, so is the break-even point. So the break-even point is the quantity where our net income equals 0. So that's going to occur at the point where our price per unit equals our average total cost. Therefore, net income equals 0. So that here's our demand curve, here's our marginal revenue curve, the blue line. Here's our average total cost curve. The marginal cost curve intersects the average total cost curve at the minimum point. So at this point here, the price exactly equals our average total cost, and so we have 0 net income. And so we're breaking even. We're breaking even. Anyways, but the point is the same. This break-even point is also the point where marginal revenue equals marginal cost. So we have this principle that determines our optimal quantity of output. Okay, so that's all I'm going to do for the first part of chapter 9 here, and then I'm going to do a second video for the second part of the chapter. So talk to you later.